All right, so today we're going to look at what's called maximum minimum values on an interval. So we're looking for high spots and low spots. Now we have different names for these spots. All right, so I got three different types of graph, or three different graphs here that look very similar. But here's how they're a little bit different. Is that if I have this first curve here, it goes a little bit up and then down and then back up. Now this spot right here at the top is the highest spot, and so what it is called is a absolute max. So that's an absolute max value, where down below this is the lowest spot of the whole curve that on this interval that we happen to be looking at, and so this would be called our absolute min. Now I go over to my next curve here, and again they all have the same shape where they go up and then they go down and then they go back up. Now I can see down here at this very, very bottom, this would be our absolute min. Let's see here. It is the absolute lowest spot. Whoops. Now, what we have down here is we have another low spot in this graph, right here. And it is not the lowest of mins, but it is a bottoming out of sorts. And so this would be called a local min. Now, in terms of maxes, this is the absolute highest spot of this function on this interval. And so this would be called the absolute max. Now, this spot here, it's nothing. That's just an endpoint. Now, I get to the third graph here, where again I look at the very, very highest spot up, way up here. That would be my absolute max. And down at the very, very bottom on the other end of this function, we would have the absolute min. But then we have these other spots of interest. Say, for instance, let me see, get my blue dot again. Right here, there is another peak, and so it is not the highest spot, but it is a peak, and so that would be called a local max. And in the same way, we have another bottoming out, a valley, if you will. It's not the lowest spot, but it is a low point, and so that would be called a local min. Now, the one thing, well, we're going to go through a couple things here, but the first thing is that the one key thing is that note, there is no local max or min at the endpoints. So you can have a absolute max or absolute min at any spot, but you can't have a local min or a local max at the endpoints. That's all. Now, finding the max or mins. Now, if a function f of x has a derivative at every point, so it's continuous on the interval between a and b, we can calculate f of x at all points in the interval, which is true, and we can find out where the derivative equals 0 and the endpoints. So what we're going to look at is, if we want to say, for instance, my last function here, if we want to find out what the absolute max is, or min, what we can do is test the endpoints, but then we can also test these local max or local mins, if they exist. Now the key is, the endpoints are going to be given, But how do we find these local max or local mins? Well, we're going to find the derivative because it's going to be the function for the slope of the tangent. And these local maxes and local mins, and this is the key here, have their slope of their tangent at that point is a flat line. In other words, the slope of the tangent at a local max or a local min is equal to 0, which is what it's saying right here, number 1. So we check out where the derivative is equal to 0, because again, that's where the slope of your tangent is, a nice flat horizontal line. And then you also have to test the endpoints. And then when we check those values out, well then we can determine which is a max and which is a min, and if we even have one. All right, so for example number 1, determine the extreme values of the function f of x equals that function right there on the interval between -1 and 5. All right, so the first thing is I'm going to look for local maxes and local mins, and I'm going to do that by finding my derivative. So I've got f prime of x is equal to, let's see here, 3 times -2 is -6. And then we're going to have an x squared. Then the derivative of 9x squared would be positive 18x. And then the derivative of 4 is 0. All right, so that's my derivative. Now, I want to find out areas where the slope of the tangent is equal to 0, or where the slope of the tangent is a horizontal line. All right, so I'm going to set f prime of x equal to 0. That's what that means. That's where our derivatives, or where our horizontal lines are going to occur. All right, so I have my -6x squared plus 18x is equal to 0. All right, so, well, this is a quadratic, and I happen to be able to factor it fairly easily out. So I can factor out a x. Could probably factor out more than that, but no big deal. So I'm going to have a -6x and then a plus 18 here in brackets. All right, so now I'm going to solve both pieces here. So, well, the first one's easy. That's just going to simply be x equals 0. Well, there's one point where there's an extreme or a possible local min, or, well, there is a local min or a local max, not sure which. All right, now I got to solve my second equation here, where I got -6x plus 18 is equal to 0. All right, I'm going to move, I don't know, I guess move the -6x to the other side. Doesn't matter. Change a side, change a sign. And, of course, I divide both sides by 6. I get x equals 3. All right, so I've got my points, the x values, where this function has a local max or local min. And then we have our endpoints. So now what we're going to do is substitute these 1, 2, 3, 4 x values into our original function and see what we get. All right, so, well, we'll start with the endpoints first. So we'll go with f of -1. All right, so let's see here. X cubed, or -1 cubed is -1 times -2 is 2. Let's see here. -1 squared, that's going to be a plus 9, and then plus 4. So let's see here. I end up with 13, 15. 15. All right, so that's one endpoint. Let's try the other endpoint, f of 5. All right, so let's see here. Oh, that's going to be a big number here. So I'm going to do some calculating on my calculator there. So let's see, x cubed. So 5 cubed is 125. I'm going to have -250. Yikes. All right, and then 9 times 25. It's 175, I believe. Oh, I better make sure. I don't want to mess this up. 9 times 25. Yeah, 225. I would have messed that up. All right. And then plus 4. And that is going to equal 25 minus 25 minus 21. Oops. All right, so there's my two endpoints, but then I also have to check out my two local max and local mins, and then I'll find out what we have here. So let's see here, f of 0 and f of 3. So f of 0, that should be easy to do. That's just going to be 4. All right, and then we got f of 3. And again, when I pump that into my calculator here, got it on function here, we get 31. All right, so now I compare my values, and let's see. So for a minimum, what's the lowest? We've got negative 21. So therefore, there is a absolute, or I should just say, yeah, we're just going to go with max. A max value happens to be an absolute value. That's what we're looking for. Oh, we're looking for, I got a min here, not max yet. I got a min value at, or of, I should say, negative 21 at x equals -5, and a max value of, let's see, 31 it looks like, at x equals 3. And there we go. So we had some local max or local mins. Looks like f of 0 was a local min, where f of 3 was an absolute max. All right, and then we one of our endpoints ended up being our minimum value. All right, so again, we set the derivative equal to 0. We find out where we potentially have max or min values within the interval, and then we also find, and then when we do find those values, we test them out as well as the endpoints. All right, so let's try a couple more of those. The amount of current in amps in an electrical system is given by the function right there, where t is time in seconds, and our intervals from 0 to 5. Okay, determine the times at which the current is at its maximum and minimum, and the amount of current in the system at those times. All right, so let's see here. All right, so we have our derivative, and I'm going to find c prime of t, find out where we have potential max or min values. So again, I'm going to take the derivative, so I'm going to have negative 3t squared plus 2t, and then plus 21. All right, so now I'm going to set that derivative equal to 0. Because again, I'm doing that because I want to find out where my possible max and min values are. And that's where our slope of our tangent would be horizontal line, which means it has a slope of 0. All right, so now I'm going to set my derivative equal to 0. So I got negative 3t squared plus 2t plus 21 is equal to 0. All right, so this time I got a quadratic equation. All right, that again I got to solve. I've already got a 0 on one side, so let's see here. I got to have a negative 3t squared on this side, on the top right, and 21 down here. All right, so I got to do the cross multiplying. It's got to add up to 2t. All right, well, 3t squared, I'm going to go with negative 3t and t. And 21, let's go with, I don't know, 3 and 7. Okay, so let's see here. Negative cross multiplier, I got negative 9t plus 7t. That's negative 2t. There we go. So switch it up now. Put a minus sign in front of this t. So 9t minus 7t. So there we go. That's factored. So one of my factors here is 3t plus 7. And the other factor is negative t plus 3 equals 0. All right, so I got to solve each piece. So the first piece there, I've got 3t plus 7 is equal to 0. All right, and if I do a little bit of rearranging and solving, I get x is going to be -7 divided by 3. That's my first solve. All right, and then I got, let's see, -t plus 3 equals 0. Well, if I just move that -t over to the other side, I'm going to get t equals 3. All right, so there's our two values. Now here's a situation. The reason I have this one is -7 over 3. That's like -2.13 or 2.33, -2.33, and I can cross this out. This is not in the interval. Our interval is from 0 to 5. We don't even have negative time, and so I'm only going to check 3 points. I'm going to check t equals 3. 0, this x should actually say t, and 5. All right, so we'll start off with c of 0, I guess. Try the endpoints first. And let's see, I plug 0 in, and good for this electrical system. There is no current running through it, which is the amount of charge, which is that's a thing that'll hurt. All right, and so t equals, or c equals, I guess I could do 3. It's one of our values. All right, so let's see, c equals 3. -3, I get -27 plus 9 plus 21 times 3, 63, plus 63 for a grand total of, let's see here, calculator going, 45 amps. Ooh, that's a lot. All right, then I'll check my other endpoint, which was c of 5. And so I get to, let's see, -125 plus 25, and then plus 105, and for a grand total of 5. Yeah, 5. There we go. All right, so we've got our values, and now, well, clearly 0 is the lowest, so the lowest current. Sorry, not typing it out. Just again, a little bit of an arm's getting sore here. The minimum, there's our min, of 0 current at t equals 0. And then our max is 45 amps of current when t equals 3. There we go. So again, there's where we got one of our points was a local min, and then one of our endpoints happened to be the local max. All right, so let's try one more of those guys. A little bit tougher situation here. All right, so example 3. The amount of light intensity on a given, or on a point, is given by the function I of t equals that function right there, where t is the time in seconds. And our interval here, again, that should be a t, is between 0 and 14. Determine the time of minimal intensity. So we're just looking for the min here. All right, so we're gonna have to test our two endpoints there of 0 and 14, but then we're gonna need to find the derivative here to see if we have any more possible max or min values. So I gotta find this derivative. All right, now what we have here is a quotient rule. We have a function divided by a function. And so I have to take the derivative of the top function, just following the quotient rule here, which is going to be 2t plus 2. All right, times it by the bottom function, which is our t plus 2. Subtract our first function, our top function, our numerator function there, which is again a t squared plus 2t plus 16. And then multiply that by the derivative of the denominator, which, it's just 1. So it's not going to change nothing there. Just multiplied by 1. All right, and then, of course, can't forget the divided by our denominator, which is just t plus 2 squared. So our denominator squared. All right, so that's our derivative. All right, so I'm going to simplify this a little bit. All right, so I've got our derivative. And let's see on the top there, do a little expanding. So 2t times t is 2t squared. All right, then 2t plus 2, that's going to be, or times 2 plus 4t. Then 2 times t is, well, plus 2t. And then I get 2 times 2, which is positive 4. Now, in our second part, this minus sign here, it's like timesing everything by negative 1. So I'm going to have a minus t squared, a minus 2t, and then a minus 16. And of course, that's all divided by t plus 2 squared. So I'm just simplifying this derivative yet. I haven't even set it equal to 0. So what do we got here? Simplifying things. I've got 4t plus 2t, and I got a minus 2t. So these 2t's at least are gone. All right. Is that minus 16? Oh, yeah, it's a minus 16. All right. So let's see. You still can simplify things. So I've got I of t. I got 2t squared minus a t squared. Well, that means there is just a t squared left. T's, I just have 4t. And then plus 4 minus 16, I got a minus 12. And then I have again on my bottom t plus 2 squared. All right, now here's something key, and this is why I like or have this example, is now I'm going to set my derivative equal to 0. Whoops, derivative. Put the little prime sign in there. Okay. But here's the best part about this one, is that when you're setting a derivative that's a fraction to equal to 0, all you need is the numerator to be 0. It doesn't matter what the denominator is, other than the fact I know that t can't be equal to negative 2, because then it would be undefined, but our interval is from 0 to 14. So all I'm worried about is setting the numerator equal to 0. And so I'm going to have t squared plus 4t minus 12 equal to 0. All right, so again, I'm going to factor this. It's a quadratic equation. So I got t squared on top left here, minus 12 top right. When it's t squared, it's got to be t and t. And let's see here, 4t, I got this one, 6 and negative 2. Because when I cross multiply, I get negative 2t plus 6t. Well, yeah, that gives me my 4t. And so one factor here is I get a t plus 6. And then I get a t minus 2 equals 0. All right, so then I got to solve each piece. Well, t plus 6 equal to 0. Well, t is going to equal negative 6, which I'm not even going to use because that's not in my interval. So that's not a point that we have to worry about. Then we get t minus 2 equals 0. Move the t or the negative 2 over to the other side. I get t equals 2. That point is going to count. So again, this negative 6, not in the interval, so we don't have to worry about that one. So the points I'm going to test are 0, 14, and 2. And there's my function right up there. All right, so let's see here. So t of, let's go with I of 0 first. Seems like always the easiest. And what are we going to have? I of 0. On the top, we'd have a 16, and on the bottom, we'd have a 2. 16 divided by 2. So I of 0 is going to be 8. All right. Wouldn't that be nice if they're all that easy? All right, so I of 2. So again, I'm sorry if I have to keep scrolling up. I of 2. Well, the bottom's going to be a 4. What about the top, though? 2 squared is 4, plus another 4. Plus 16, so 4 plus 4 plus 16 when I put a 2 in there, so that's going to be 24. And 24 divided by 4 is 6. Okay, so that's we're looking for minimum so far. All right, we got one endpoint more to check out. That's, oh boy, 14. Got a sub in here, I have 14. Let's see, in the bottom I know it's t plus 2, so 16 in the bottom. Great, now up top. 14 squared is 196, okay? And then 2 times 14 is 28, so hold on here. 196 plus 28. I believe the last one was just 16. Yep, just a 16, all right. And when I sub those in, let's see here, 196 plus 28 plus 16, let's see, and then divided by 16 is 15. And so the question asks, we've got our values here of 8, 6, and 15, and when is our light intensity at a minimal, the time? Well, that time would be t equals 2. And the minimum intensity would be a rating of 6, I believe. I think it's just a rating. Yeah, I think it's just a rating. So t equals 2 is our answer. And again, that's when your intensity would be classified as a 6.